All right, new day and another laptop that needs to be saved, and this time we have a Precision 5530. Now, this was sent in because the motherboard no longer turns on. They said they smell something burning, but the major thing here is that the drive is encrypted with BitLocker, and they don't have the key. They can't find it anywhere. One of their old employees must have encrypted the drive and stored the key somewhere. They're desperate to access this data, and the only way to do it is to fix this motherboard. I haven't taken a look at this yet. Let's take a look together and see if we can get this figured out. All right, so if you're not familiar, BitLocker is a drive encryption that Microsoft pretty much always enables by default without telling you. But usually what's happened is it's actually attached to a Microsoft account and it uploads that key. So it's stored safely. We can recover it very easily, or I can help the customer log into their Microsoft account. Apparently that's not how this one was encrypted. So let's go ahead and just start by just trying to turn it on and see what it does. Now I do see the keyboard backlight coming on. All right, so it is actually powering on. I thought it didn't come on at all. So we can see that. Let's see if we get a picture on the screen. It did shut off, but we still have a power light up here in the front and then it shut off. But I still have the keyboard backlight here. And did you see it blink for a second? Okay, that's kind of strange. Let's plug in the charger and keep an eye on the power meter right here. Now, the worst case scenario, if this ends up being some sort of BIOS issue, then we're gonna be in major trouble because the BIOS is where it actually stores the BitLocker encryption key, or there's a separate TPM chip on these. A lot of these Dells, it's stored inside the BIOS chip itself or in a BIOS region. Now, this thing is still on. We're pulling 1 amp. I don't know if that's charge current or not. I'm gonna press the power button again. Okay, there it goes. It's trying to come on, but we're only going to 0.2 amps, and then it kind of blips up to 0.6 and then back down. Now the normal process should be where it actually starts pulling over an amp. And even if this thing is actually going through some sort of CMOS reset or something like that, it should be moving around a little bit more than that. Having this little cycle like this is either indicative of having a BIOS issue or having some sort of short on the motherboard somewhere. So if it is seeing a short, it's probably not on the main power rail. It's gonna be on one of the lower power rails, like a 3 volt or 5 volt, somewhere else that powers like maybe the SSD or something like that. Again, the drive is encrypted, right? So if we just took the drive out, try to plug it into another machine, it's gonna say that we need the BitLocker encryption key. So what we're trying to do is get this board to boot up long enough to be able to access that BitLocker encryption key. Let's just go ahead and open the bottom up. I just wanna take a look inside. Then we are missing one screw on the bottom here. Now this is an older machine. This is probably circa 2019. This is prior to them going to only USB-C, so it actually does have a barrel jack. It's gonna be one of the smaller 4.5 millimeter barrel jacks. All right, and the bottom is off. Here's our drive. This is gonna be the SSD that's encrypted with BitLocker, so can't access the data if we pull the drive out and put it into something. They've already tried all that. So this machine has DDR4. Here's the main battery. We can just try doing a CMOS reset, just unplug the battery. There's also a CMOS battery underneath the motherboard, so we could try pulling that off and resetting it that way. Right now, if we just unplug this, it's not gonna fix anything because these machines actually have a tendency of having the CMOS battery kind of go in a low state and mess up the EC chip programming, and the only way to reprogram the EC chip is to unplug all the power and let it reprogram itself. When I open this, I thought I smelled something, and I do. There is some sort of burning smell, and they did mention that. So I don't know exactly where this is coming from. Let's get under the microscope and we can take a look around. So right here is gonna be the CPU, I believe, and this is the GPU on that side. Here are the power stages for the GPU. These are the power stages for the CPU, so each one of these kind of work together to power that. Oh, there's something burnt right there. We're gonna have a bad CPU. That's gonna be one of the worst case scenarios also. If we're not able to fix this board, then this customer's data is gonna be toast. So I do see that we have some sort of blown resistor here. I also see arcing on the edge of this. You know what this means? This means that probably someone stuck a tool in here and sparked it. That's exactly what that means. Is this repairable? I don't know. I have no idea. But I can definitely smell some burning. Let me pull this heatsink off so we can take a better look at it. So I don't know the exact scenario. They did not tell me that somebody was working on it and then damaged it, but that's kind of what that looks like when we have arcing on the edge of something like that. Now, if I just saw the resistor blown, then I'd be like, okay, maybe the resistor just blew up because it was like pulling too much current through that or something like that. But that inductor having that little mark on there really looks like there was some sort of tool that shorted out. Now, if you leave the battery plugged in, then we always have that power rail right there energized because that's gonna be like a 12 volt power rail. This machine runs on a 12.6 volt power rail. Oh gosh, okay. We might have something worse. So we see board layers burned right here. See that? So this via right here is all burned up. This resistor is definitely probably blown. We could see melting metal right here, melting right through that. That actually might be shorted on. Usually resistors will blow. So these aren't measuring as anything, but I'm in continuity mode. Let me just go to straight resistance and see what those are measuring. So we got 8K, 8.3K. Oh, okay. Well, when I was just measuring that, it just popped off of here. So that means that this whole area has been busted. Okay, well that's burnt, broken, damaged. Do you think if just replacing this is gonna fix it? I don't know. Let's measure the main power rail on here. Just wanna see what resistance we have here. That's gonna be that. 0? Oh, okay. For a second, it looked like it was gonna say 0. We're at 1.6K, so that's fine. So yeah, when I was just applying just a little bit of pressure, because I have to poke my probes in pretty good, it just popped right off. So this may mean that it's just missing that signal and it shuts off, or what? I don't know. Let's clean this up to see how bad the board layers are here. I wasn't expecting this, actually. I was kind of expecting something less catastrophic. Board layers is not something that we want to see when we're working on something like this, where we have to rescue vital data. Okay, so signal-wise, we have a wire here that can be reattached. And that goes where? Are all these in parallel? I don't know if you can make that out or not. Let me dry this off a little bit. All right, so we have a signal that comes over here. Does it go through the board right there? There's a via there. These almost look like they're all connected. We can measure that and see if they're connected. The thing is, what I'm trying to just kind of think through is like, okay, I'll put a new resistor here. What does it connect to? Because we don't have a schematic for this, so we're just kind of figuring out what is connected to what. So if I touch these two, those are 38 megs, so that's open. If I connect here, that's an open. What does this connect to? And what does that connect to? Does that connect this one, and this one goes, well, it goes over here, right? Okay, so it's connected to this. It goes through this resistor. So this resistor, 7K, 6.9K. All right, let me see if we can just grab a donor board or something, a similar board at least. I want to see what it looks like, what the layout is, see if we can get this rebuilt. We still have to pull the board because we may end up having something that's on the other side too, but I just want to at least start out by looking at it this way. All right, so here's another board. It's nice to have reference boards here. Let me clean this one up. There's a little bit of dust on it. All right, so here's what I'm seeing. I don't know if you can make it out. I can make it out just enough. So we have a connection here. Goes through and then goes on this line. This line actually comes over here, but then it connects through this via to the other side of the board or to somewhere else. And then this one is the other one that's all kind of burned up. So we can connect this to here. That's not a big deal. But we need to be able to connect into that via there in order to get that working. Now, I don't know what this is for. I don't know what it does. I have no idea. So there's our hole. That's our via that don't really see any signal there. Now, I don't know where that goes. If we knew where it goes, then we can just run a wire to get there. Is this one not attached anymore either? Because it looks like it's kind of moving around a little bit. Yeah, it's not even attached anymore either. This thing got burnt. Let's see what it does now that we took all this charged stuff out of here. I'm gonna clean it just a little bit more. I'm gonna try turning it on and we'll look at it under the thermal camera. We wanna see if the CPU is actually coming on or if it's still blipping up and down. But before we do that, let me go ahead and pull the drive out because the most important thing is actually to save their data. So I need to set this off to the side. We wanna get this out of the picture so we can keep it safe. And then we can go ahead and just plug this in under the thermal camera and see what it does. All right, I'm gonna turn it on. Ready, 3, 2, 1. All right, so the CMOS battery should be good if it's not powering on its own because I have the main battery unplugged, and if the CMOS battery was dead, then it would actually power on its own, so I have to open the lid, press the power button. So, whoa. Whew. Okay, I didn't see that, and I didn't expect that. So how did it get worse? So we ended up with burn layers through the board. This is not good at all. So the holes were worse. I took off all that stuff there. I don't know what we captured on the video or not because I can't go back and look at it right this second, but we saw a lot of heat. This conclusively says that this motherboard is done. Now we can tell that somebody had actually taken their tool and caused this in the first place, but I definitely did not think that we were gonna have a huge burn that would come right through here. So even if I would have tried to rebuild this first and like tried putting a wire in there was nothing we could do. So now we're at the point where we're like, okay, what can we do to actually recover their data? Because all the stuff is actually built on the board, all the encryption stuff, the TPM 2.0 module, which I think this one actually does have a separate one. Here's our donor board. Let's take a look here. Yes, so this does have a TPM 2.0 separate module. Now, the theory would be you could probably just transfer this over to the other board and then maybe access it, but a lot of times the information is actually stored in the BIOS that allows it to connect to the drive properly. And manipulating a BIOS and then putting it on another board in order to make it compatible ends up wiping out the information that is needed to access the BitLocker. So we're kind of in a catch-22 if we can't get this board fixed. All right, let me go ahead and pull this motherboard out. Let's just see how bad the damage is. I mean, I'm pretty sure this thing is toast at this point because when you have a motherboard released that much smoke, and I don't know how much showed on the screen, but I had a lot of smoke in front of me. And it was already burning, obviously, and all we did is kind of remove the stuff that was already burnt out of the way and just kind of test plugged it in, which is a normal process to this. There was nothing that I could have done in order to make it where, let's say, try to put the wires back in or something like that, because that via was already burned up. Trying to attach a wire down inside of a burnt via like that is already difficult. That's why I kind of wanted to see if there was anything hot. And then a lot of times you have to kind of check to see if any board layers are shorting together and doing any arcing. I feel bad for this customer, I really do, because if this truly is something where you cannot access the data and maybe it has some crucial company data on it or something like that, the 321 is kind of what you're supposed to do. You're supposed to have 3 copies. You're supposed to have 2 local and 1 off-site. And the thing about having a BitLocker key that's automatically enabled by Microsoft, that is the most nutty thing I've ever seen. And we have customers come in pretty much weekly saying, I don't have BitLocker encryption, and Microsoft has automatically enabled it without them knowing. And they're doing it even on home editions. They used to do it only on Pro editions, which this is a business laptop, so it would probably be enabled. But you have this situation where they enable it and it's supposed to store to your Microsoft account. That's why they want everybody on the grid, you know, inside the Microsoft account. But if you can't access that Microsoft account anymore, which has been kind of the weird issue, you know, you have somebody who has set up their Microsoft account years ago, or even used an email address they don't use anymore, or they only use just to set up the account for a second, and then they're not aware of it or they forget all about it. We kind of nudge people in the direction and go, okay, well, what were you using in 2017 or whatever? This is 2019 laptop, so what were you using 6 years ago? Ooh, I can see some burning right here. I don't know if they've already went down that whole train of just trying to get that, but I'll do the best I can. I'm not doing data recovery. I am actually doing board recovery, fixing a board, and the byproduct is saving their data, right? Looks like the thing is burnt right there. Is this, it burned all the way into the keyboard. Wow. Let's see what it looks like here. So this was, let's see, in this orientation. So this is here. This is our burnt area. I want to look at the other side of this thing. Oh my gosh. So here's kind of what I think happened. I think somebody was in here working on something and their screwdriver slipped, sent 13 volts where it wasn't supposed to, and ended up messing up the board layers in here. This is the via probably that was connected to the other side. Here's that other via that we saw burned up too. So all of this inside of it, we have a bunch of layers together and there's supposed to be some sort of insulator. If that gets damaged, then we have a lot of issues. So here's the PWM controller that actually controls all these power stages for the CPU. So even if this was recoverable, the CPU may be damaged anyway. But this is all gonna be the main power rail right here. This 12 volts, and I don't think these were supposed to be high voltage. These are all high voltage right here, and these are going to be the lower voltage. So yeah, we're in trouble here. We're in trouble. So here's my plan, and I don't know if this is going to work, but we're just going to have to do what we're going to do. Oh, well, never mind. I was going to say, here's what we can do, but I think we just basically ruined everything. So here's a BIOS chip, and the BIOS chip stores a lot of the information that's crucial, right? If this BIOS chip has been messed with and the data is not the way it was whenever it booted that drive, there's nothing we can do. Nothing we can, I can't even do anything. Because my theory is gonna be like this. I'm gonna back up this data and I'm gonna save it. And then here's his TPM 2.0 chip right here. And I'm gonna transfer this to a working board. And then I'm gonna transfer his BIOS to a working board and see if we can get that board to fire up. If we can get that board to fire up, then we might be able to access the, it won't run right because it's not actually configured to that board, but sometimes you can get them to turn on. And if we can get it to fire up just enough, we can get it to boot and access the data. But if someone's already messed with this, it shouldn't have even come to me because there's nothing we can do. This board's messed up. All right, well, let's just do it. Let's just back this data up real quick. What chip do we have here? It's a 25B256D. So let me get my chip reader out and we'll back up that data. I'm actually pretty irritated right now. Hopefully this is, whoever messed with this backed this up. So if this data in here is not correct, then we can get it from whoever backed it up or messed with it first. But maybe the person was just trying to get the key out of the BIOS maybe. All right, let's see if the chip is detected. Hey, it's detected. Well, that's good news at least. B256D, that's our chip here. Actually, we'll do WSON. Let's read it, see if we have contents. And we do actually have data on it, which is perfect. Let me verify that data and make sure it matches. All right, and the most important thing, save the customer's BIOS information. Save it. So hopefully whoever messed with this did this already, but I'm gonna do it again. All right, so I have that saved. So now the next kind of plan of action, we don't need to pull that chip off. So whoever soldered that back and forth, they didn't need to, they could just use one of these chip readers. The other thing I wanna do is we're gonna move this over to another board, but I have to get a board that is the same thing. And I just need to make sure that we have a board that is the same. I have a donor board here that, let's see, cannot load the GPU driver. So this means that this board actually does work. It just has a GPU issue. Now, I think this is a XPS 9570, and it may be too different because those are the same generation. They're actually released at the same time. It just has a different GPU. But what I want to do is I want to make sure that the board is actually the same other than that information. The board prints the same. It has it's a G341P, and so both of the board prints are the same, but the part number of the board is actually a XPS. And so I just want to make sure that the BIOS information out of here matches the BIOS information out of here. Sometimes they have like a corporate ME region versus a consumer ME region, and I want to make sure that that's not going to clash because I have new ones in stock, but I don't have a used one that I want to solder on. That's the thing, is I don't want to mess with my good boards, my new boards, unless the customer wants to buy that board or something like that. And this is all testing anyway. We don't even know if this is going to work. It's for science, right? That's what we like to say. We're doing this stuff for science because at this point, most places would have just said, sorry, there's nothing you can do. Your board just blew up. Your data, you're going to have to go find your key. But for science, I want to figure out if this is even possible. We don't even know if it's possible. Trying to transfer these things over, we're in the unknown territory here. So here's what I want to do is I want to take a look at their ME region on their backed up BIOS that we just had here. So I'm going to pull up our ME analyzer and let's take a look at their BIOS information. And so here's their BIOS file right here, and I need to drag it onto our ME analyzer and then see what that comes up as. So this comes up as corporate H, and it is a production 12. And so I've already pulled the BIOS information off of our test board that we're about to mess with, so I can kind of figure out and we'll compare it. And if it's too different, then I'm gonna have to keep digging and seeing if we can find a precision board. Yeah, so here's off of my donor board. So it looks like this is matching. If we pull them both up side by side, they're pretty close. I mean, they're not gonna be exactly the same, but the main thing I want to see is that we have corporate H, we have all this stuff matching here. The ME version is a little bit different, but that's not going to be a big deal. But see, the thing is that they're both initialized. And when you take an initialized ME region and put it on another board, it usually doesn't work. But I have seen it sometimes post. It just acts a little weird, doesn't want to power very fast, and you have these weird things going on. So things we do for science. Okay, so I'm going to transfer their TPM 2.0 module off their bad board onto this board. And then I'm going to flash this BIOS chip with their BIOS information. Well, let's just try not even flashing their BIOS first. Let's just move the TPM 2.0 over and boot it up. Actually, I want to do them both. I'm going back and forth because I don't want to mess up what we have, right? So if their TPM is set a certain way, I don't want it to change. And so we only really get one shot at this is kind of what I feel like. I don't know. I mean, I think the shots have already been kind of shot at, right? So it's like, am I really the first shot at this and I'm going to end up damaging this, or is it we've already went through a few different repair shops and then on the last ditch effort is really what it is. But anyway, did we even look at their drive? Let me plug in the drive into the computer and see if we can even access their data right now. All right, so I just have one of these like USB NVMe adapters. I'm just going to plug that in. And so if we plug this in and it says you need a BitLocker key, then that will be it. Yep, so it says BitLocker encrypted, access denied. So that's what we're looking for. Nothing we can do. If we try to do this, it will ask to type in the BitLocker key. There's no supported protectors on this drive, so it can't be unlocked. So this means that this is even worse than we thought, because normally when you plug in a BitLocker encrypted drive, it will ask you for the key right here, and then you can access the data all you want, just like that. But somebody's already messed with this drive. So again, even if we boot this machine up and get the key, will they be able to access the data? Now, if we're able to boot it up and maybe disable BitLocker, that'd be one thing, or we're able to, although we're not gonna be able to log in. I don't know, maybe we'll be able to log in. I have no idea. We're in unknown territory again. This is all, we'll see. Hopefully you guys are on my side on this one. I'm gonna go ahead and flash their information on here. Let's actually install this test board into their machine. Let's plug the drive in. Let's see if we get a BitLocker screen, because at this point, if we're not even getting a BitLocker screen when it's in a machine that's working, then what is all this for, right? We're wasting our time. We're spinning our wheels. So let me get this installed and see what it does. All right, I got the motherboard installed. Before I plug the drive in, I just want to make sure it turns on and works. So this will take a second to get through a CMOS reset, so I'll be right back. All right, so the board is working. We verified that. Now we can plug in the drive and see if it boots off of it. What we want is it to ask for a BitLocker key. That's what we want. So their drive is plugged in now. Let's plug it in here. I'm pretty surprised that it didn't ask for the BitLocker key when we plugged in the drive into the machine, into our desktop. So I'm kind of worried at this point, and I'm hoping that somebody hasn't manipulated this drive too much. But whoever it was sent to, maybe they backed up the drive first. They have a clone of it somewhere. Maybe they have a clone of the BIOS somewhere. Maybe all this stuff is backed up and it's easy to get back if we need it. But I am not a data recovery company. I am a motherboard repair person. So all I'm trying to do is fix the motherboard, and I'm trying to transfer their BitLocker stuff over to another motherboard, but we'll see what happens. Never done it before. All right, we got our Dell screen. Moment of truth. I can still smell burning. It's crazy. It must be on that palm rest. All right, hit continue. Come on. Preparing BitLocker recovery. I like it. Restart. Looks like there's something didn't load correctly. Restarting might fix the problem. Someone has cooked this BitLocker drive. This is all a waste of time. I mean, I'm still going to continue, but this is just a waste of time. We should definitely get to a screen that says BitLocker somewhere in there. Nope, see, it should not do this. This is actually after you hit escape, so you should get a BitLocker screen first, then you hit escape, then you'll do this, and then it will take you to another screen where you type it in. So somebody has messed up their BitLocker. They must have been trying to manipulate it, trying to access it. I still want to transfer the stuff over anyway, but I don't know. You know, we're doing this for science. At this point, I've gone this far. We might as well finish it out. But I feel like what we have going on here is a case of other people touched it first and made it worse and makes it where it's not fixable. Okay, so here is our TPM 2.0 module. And so we need to remove that off of this board. This is our test board. We'll take it off of their board and transfer it over here. Then we're gonna write their BIOS onto this board. And it'll be crazy if it just boots up. I don't know. My mind would be blown, but all right, so let me go ahead and remove this one off of here. Okay, I'm just gonna set this one aside. This one's a good one, but it doesn't have the data on it that needs to be on there. Let me grab the customer's board. All right, so here's the customer's TPM. So this is gonna be the most crucial thing that we wanna keep safe, assuming that it has data on it that needs to be on there. All right, I'll set it right here. Let's get it installed. A little bit of flux. There we go. That looks like we have a couple pads that are touching together here, pins. Did you see that? I didn't miss it. All right, there you go. That's why you have to double check. Okay, so that part's done. I guess that would be more of the hard part, I guess. And then this is the BIOS chip on this machine. We're gonna overwrite the data that's on here. I don't really care about it. And we can put their information on there. So I'm gonna load their backup BIOS onto this one. Now, theoretically, it shouldn't work on here, but I've seen it work. So, like I said, it sometimes works, sometimes it doesn't. This is actually a different BIOS chip, so I need to make sure we select that correctly. It's a 25Q256JV. So let's see if we can detect that. It's a QJV. All right, so it's gonna be this one right here. And we don't need to read the data because I don't really care about it. This is just my test board, but we're gonna load their backup data on here, and we're gonna program. Now on the newer machines, there is not a separate TPM 2.0. It's all inside the BIOS, and just moving the BIOS chip over will move their BitLocker key over, but it doesn't generally allow the machine to post. So that's kind of the issue here, but on these older machines, I've been able to move the BIOS chip over and have it post still. So the theory is that if we have the keys inside the TPM 2.0 module and we have the BIOS chip, the machine should work and it should boot from the drive. Assuming that they haven't messed with the BIOS and broke it, and assuming they haven't messed with the drive too much and broke it, we will see momentarily. All right, I was able to flash that on there successfully. Now, let's see if this is gonna work. All right, we have a lot of unknowns here. We don't even know if this BIOS is even any good, so we don't know if the board's gonna post, but if it doesn't post, then it could be because it's a bad BIOS or because we put it on a different board. So those are the unknowns there. And if this doesn't work, then we're out of options. And this customer is gonna have to try to figure out if there's some sort of data recovery company that can get past BitLocker, which I haven't heard of anybody that can. I know that there's some sort of like ways to bypass BitLocker, but that's only when you have a working system that has the key running on it, or if the drive's not damaged, obviously. But I'm sure people will put comments down there explaining that, oh, it's easy to get past it. BitLocker is actually a really pretty good thing to have on laptops in general because, you know, if your laptop gets stolen, then they can't just pull the drive out and access your data. I don't really mind it on a laptop. I just mind that they're not telling you about it. That's what I mind. So if we're gonna get in an argument about this, I think that it should be that you should have to consent to it. How's that? And you should know what you're getting yourself into. All right, so we have it installed. I'm at the edge of my seat here. I'm sure you guys are too. All right, fans are spinning. We're pulling some current here. It's powering on its own because we have the CMOS battery unplugged, so it's doing the CMOS reset. We still have fan spin. 30 watts. What we want is the wattage to move around, so we need, there we go. That's looking good so far. It turned off, that's good so far. 42, 76, okay, that's good. So if we got up to 76 watts, then I think we're about to post here. Fan spinning up again. We are cycling. 38, 42, 67. The suspense is killing me. It keeps rebooting. Hopefully it's not going to be in a boot loop here. We have picture. I can't believe. Okay, so we have picture. We have their BIOS on this machine with their TPM 2.0 module. So all the ingredients are here. So now all we need is this ingredient to have the correct BitLocker stuff going on and still. So let me turn this thing back off. I'm going to install it. You guys, this better work. So it's gonna go through the CMOS reset again. I have to sit through it. You don't have to. I'll be right back. Okay, we're booted back up. We have their drive installed. We have their BIOS installed. We have their TPM installed. All we have to do is hit enter and see if it works. It shouldn't boot into recovery. It should just boot straight into the operating system if it's gonna work. No freaking way. Oh, yes! Are you freaking kidding me? Well, moral of the story is, I don't know I don't even know what to say about that actually. I thought we had probably a 5% chance that we were gonna be able to access this drive's data. I mean, we haven't got the login screen yet, but 5% maybe even less than that. And now we're booting the drive. So I'll be able to log in. I'll be able to access their BitLocker encryption. I can disable it. I can back up their key. I'll be able to get all that information. I'm just hopefully I can get to the login screen. It's probably gonna give me a blue screen and say inaccessible boot device, I bet, because it's probably set to the wrong controller, or the drive is messed up still. But just having the spinning there tells me that it's accessing the drive. Boom! Okay, so this wraps this one up. So I'll be able to get into their data and take care of all this stuff. Hopefully you got something out of this. This was a science experiment. We did it all for science, and I almost wanted to give up, because we saw other people messing with stuff. But I don't know how many places it went to first before it came to me, but I'm happy to report we're able to access their data, and I would absolutely love to know what your thoughts are on this one, and thanks for watching. I saved another laptop!